Hey guys, this will be video 31 for the Gibson Les Paul custom restoration. We've got a lot to cover in this video, basically two leaflets worth, so I'm going to stay on point, and we are going to talk in extensive detail about building a fretboard now that we've decided that's exactly what we want to do. And primarily I'm going to focus on building a 25.5-inch scale fretboard, and I will refer back to the Gibson, of course, but primarily we're going to keep it simple, and all the numbers I mentioned, like measurements, will be based on the 25.5-inch scale. And let's just dive right in. All right, so the first thing you're going to want to do is you've found your choice, your prize board that you want to use, and let's say let's just say this is rosewood, and just forget the whole ebony thing, because typically if you see a 25.5-inch scale, I'm just going to start calling it a Strat. I'm going to call it a Strat through this whole thing. And when you hear me talk about a Strat, or if I mention Telly, I'm still in the 25.5-inch scale realm, and the video is rolling. So typically when you're looking at a Strat, you're going to have one of two fretboards. You're going to have either maple, and it's either going to be a one-piece neck, it's a solid maple neck, that's not going to be discussed here, or it's going to have a rosewood cap. In other words, it's going to have a maple cap. That's more typical and much easier to build. Why? Because we routed it out for the truss rod, and now we're getting ready to cover up that truss rod. So you're either going to have a maple cap or you're going to have a rosewood cap. And let's just say this is a real nice piece of rosewood, and let's omit the fact that it's a hazardous and dangerous wood to work with, but make note of that. It is extremely dangerous to work with as far as the dust. So let's say we've got our vac system under control, and we don't have any children in our house under 3 to 5 years old, because their immune system has not built up to handle things like that. You could do positively horrific damage to your family by being ignorant with this stuff. So know what it is you're doing. Discuss these things with your doctor and or the pros. So proceed with caution. All right, so let's say we've got everything under control, and we've got our prize material, and it is let's say it's warped and twisted, and it's beautiful. It's got all this incredible figure in it, but it's just in horrific condition. Don't throw it away, but put it to the side. You're not qualified to work with problematic materials yet. If you can't pick up a board and it be perfectly clean and straight and all that, even if it's in its large form, run, because you're not going to be able to handle it. It's going to make your life miserable. Again, and I'm not going to tell you, if you really were smart, you would just buy your fretboard from Steve Mac and be done with it. But if you are, I'm going to say it one more time, and then I'm not going to say it again. I really recommend not trying to build your fretboard if you've never done this before. If you've never built a guitar before and you pull off the fretboard the first time, that's going to be amazing. But since we're here, let's do it. So the first thing you want to do is S4S your board. What is S4S? 1, 2, 1, 2, 3, 4. It means that you're square on all four sides. At a minimum, you want to surface the sides, surfaced on two sides, like a S2S, and you got rough edge. This is not S4S. This is only surfaced on the top and the bottom. Why? Because I wanted to see the grain. I want to see if there's any knots in here or any light spots, things like that. That's not even surfaced, and there's no sense in surfacing that yet until I determine, yeah, I do want to use this neck perfectly down the center, and I'm going to be able to go off to the left and still be, in other words, find the center here, let's say we're going to be, we're going to be 2 3/16. We're not doing any binding. So we're 2 3/16 finish. Don't, don't do your initial rough out 2 3/16. Somehow or another, it's going to end up at 2 1/8. Don't ask me how, but it's going to end up too small. Always be about a 1/16 of an inch wider. So we're going to rough this thing out probably even more than 2 1/4. And then up here, and also keep in mind, I shouldn't even have that down on the bottom. You want to have about an inch space down here so you can run a screw through it once we put it in our jig. You want to have about an inch, if not more, up at the top so we can run a screw up there once we're centering everything. But let's say that's going to be our target, and we know all's well. Well, then we come in with our mechanical pencil. I may be getting ahead of myself. Let me back up. Yes, S4S the board. So let's say we are just going to S4S it. It's surfaced on this side and on that side, and I'll talk about surfacing later. You're not going to be able to surface a piece of rosewood 3 inches wide on a table saw and it look like that. That's not going to happen. That's done with a thickness sander. But when I say S4S it, run it down the table saw and clean up these edges. And let's just go ahead and work it down to say 2 1/4, or at least over 2 1/4, all the way up. And then let's say that we don't want to put the fretboard on a crazy angle in order to pick up some sort of incredibly beautiful figure or something like that. Run out is not very important on something like this. I say that cautiously. You don't want to be, you don't want your fretboard coming out of a piece of material like, if this is the grain. But if you need to pitch that fretboard over a little bit to avoid a knot, do it. It's trust me, that you'll be fine, and you'll really appreciate it. Unless that knot is directly in the middle and it can fall directly under a mother of pearl location. But don't be careful with stuff like that, because it'll haunt you through the whole design layout, so much so that you'll end up overlooking something that was far more important. So we got an S4S board, and it's 3/8 of an inch thick. That's a monster. Now the next step is we determine our rough out location. Now that we've got it, visible, and it's 3/8 of an inch thick. And then what we're going to do, we're going to take our fender strat template that we decided we're going to work with, and we're basically just going to take a pencil and go around it. But say that cautiously. Make sure that if this is your this template will be finished when you do your pencil work out here. Remember what I said about dash lines? Maybe make dash lines. And then when you do the dash lines, make sure to draw an arrow that reveals to you. Make sure you rough it out a little bit bigger. This is all natural, and I'm not going to hold your hand and be condescending. So just rough it out a little bit big. All right. Next thing you're going to do is, why do you want to rough it out? Use positive versus negative space. I better cover this. To me, I'm using a positive space template to rough this out. Why? Because I've got a beautiful board back here. I can put this thing anywhere I want. But if I got some sort of weird figure going on that maybe is insanely beautiful, I may decide, oh man, that needs to be the nut location, and this needs to be the upper register location. And then, oh man, I know if I can capture this figure here, and you'll start seeing, well, possibly at that point, maybe create a negative space template where you've cut out the actual fretboard, cut it out a little bit big, always remember, and then lay that negative space template so that you've got a border, that exposes what you'll be, where your visual fretboard is going to be. Then lay it out per that and draw your lines. All I want is rough lines right now. Okay, after you've used a positive versus negative space template, locate knots, issues, put them under the large mother of pearl locations. I've already covered that. If you can, but don't let it control you so much so that you make a mistake. Next thing you're going to want to do is glue or toggle clamp per the taper locations onto a straight line jig. And I'd recommend that your straight line jig either just be a poplar or just a real piece of nice plywood. And what do I mean by a straight line jig? I'm going to change gears here. Let's say this is our straight line jig now. And this is a piece of poplar. And it's, let's just say it's 2.5 inches wide, or it's 3 inches wide, and it's longer than our fretboard. If we drew out this fretboard location onto a board, onto this board, but now let's change gears. And now this is our template, and we're holding the board that we just drew the lines on. Well, what do we have? We have the rough nut location, and we have the rough high register location. We simply flip it around backwards on the camera, and we start pulling that up until we find that right there. Now and keep in mind, you're going to have this mass. That's exactly what you're going to see. You're going to have at the nut location, you're going to have more material, and at the upper register location, you're going to be shaving off you're going to be feathering out to non-existence. So, and then what you're going to do is you're going to do one of two things. You're either going to have dropped by Harbor Freight or somewhere like this and picked up what's called a toggle clamp, and you have mounted that little toggle clamp to your straight line surface. Keep in mind, this board will have to be wide enough, because what we're about to do is pass this through the table saw, and this is going to have to run along the table saw fence. Well, it can't run across the table saw fence if that's in the way. So maybe this toggle clamp needs to be up here like this. Okay, I'm trying to help you save your fingers. It's a shame that there's not enough guys out there showing real simple things like this that can make the difference in saving your fingers. And look how simple that was. I think these are $5 or $6 a pair, or maybe each at Harbor Freight. They're worth $150. They're worth $1,000 if it saves your finger. So, see what I'm saying? Now, if this is our table saw, and we can run this along the table saw now, and we've just cut a tapered cut just as easily as if we were cutting a straight line cut. Now do the other side, flip it over, flip it around. I'm not going to start explaining this. Common sense should be ruling by now. And now you clamp your toggle down. See, this little toggle works like this. You push down on that back there. You push down on that back there, and it starts going down. And then it goes knock, and it locks into place, and it doesn't take much to hold it in place. All right, so now that we've just passed that through the table saw, and before you make that pass, you can take this piece right here and set your fence and adjust it, and run this piece through your table saw and shave a bit of this off. Now leave your fence where it is, then come over here and glue with the if you know this trick, put some masking tape down. Put a little dab of jet glue, Hobby Lobby, $4.99. Don't go with the thin glue. The thin glue will make a mess and get all over the place, or risk dripping on something you don't want to get glue. Use the medium. Use the medium or the thick. Do one little drop there, maybe one in the middle and one down there. And then after you make that pass, take a flat blade putty knife and pry that off. Start over. Rip that tape off, throw it away, glue it down. We're looking to do four things: safety, and a precision cut. One pass. That's our target. All right, I think I covered that enough. So, a very simple way to cut anything that you want to cut on a taper, or even if you just want to straight line some stuff, you can use that straight line jig to take a rough piece of wood and straight line that board. All right, let your imagination run wild with the whole toggle clamp thing because it's incredible. I'm not even going to show you my toggle clamp straight line jig. I got to get a patent on it. It's amazing, or maybe it's already out there and I just haven't tripped up on it. As far as the board, turn the rough out, glue or toggle clamp. Why did I say poplar or plywood? Because poplar is a very good wood. It's very cheap. It's right on the shelf at any of your big box, and typically you can pull a piece of poplar off and look at it, and man, they're straight as an arrow. And if you do want to straight line it on the table saw, if you try to run a piece of maple down the table saw and straight line it, that maple's going to push that blade wherever it wants. It's very You got to have a really high quality table saw and blade to straight line mahogany. And even the same thing goes for miter saw. I cut that on a miter saw a little bit ago, real slow. It's not even square. I can't get it square on my miter saw. So maple's difficult. Use a softer wood. All right, let me stop. 25 and a half inch scale rough out. Okay, I'll go ahead and talk about this length. And I'm just going to throw some numbers at you. If we're building a Strat, it's a 25 and a half inch scale. This fretboard has got to be at least from the nut to the 22nd fret, 18.335 inches, or 465.707 millimeters. Is that too short? Yes. What do I mean by that? You've got to allow for a little bit of overhang. You'll have your last fret, and then you got to have typically whatever. If you're building a 22 fret fretboard, make sure that when you do your fret scale calculation that you cut the overhang roughly right at the 23rd fret location. If you're doing a 24 fret fretboard, make sure that you would cut that overhang at roughly the same, whatever you went from the 23rd to the 24th fret location, leave that much overhang. Let's say that was the 23rd fret and that's the 24th fret. We're getting dangerously close with that right there. Why did I have to do that? Because that's the way Gibson did it. Why? Because they went with a really wide binding. See, this is where all your binding and your layout and your engineering everything is affected by your very initial layout. If this guitar had been more of a 50s profile, I would have had this overhang. I'm just going to call it the overhang because this is going to be the 22nd fret. This overhang, I would have had this overhang about a millimeter more and then a thin binding, and it would have looked more in line. So basically, if you're doing this by going on your fretboard calculator, you're going to determine that you need to be roughly about 18 and 5/8 of an inch minimum length in the finished fretboard. So we got to have something to screw to the jig. So add an inch here, an inch there. You see 18, 19, 20, 21. So don't go on eBay and get all excited because you bought a fretboard and the fretboard was 18 and 5/8 of an inch long. You don't have anything to fasten down to your jig. All right, let me move on. Why did I want to do a rough taper first? Because now we're getting ready to move to an oscillating sander, some sort of fence. Let's see if that's in. Where are we? We're at 18 minutes. All right, now we're getting, and I'm going to clean all this off in a second. Now we're getting ready to move to the oscillating sander, and this, if you know what that means, it goes as it's rotating, and it's rotating clockwise. They run really slow. They got a vacuum system on them. So at a minimum, if you're doing like a rosewood, you can run the vacuum while you're doing this. Not going to revisit that, but then build some sort of fence. I'm not going to go there. I've got my fence. It's awesome. It works. It's just incredible. And it's low profile for certain things, and I got a higher fence for other things. And keep in mind, when this goes through and it starts coming up, it's gonna want to start doing this little zigzag pattern in the surfacing. If you surface this 3/8 inch piece down to a 1/4 of an inch, I'm just going to say a 1/4 inch is our target for this guitar. You're going to work yourself to death working this piece down. And because you're going to find in a minute, we're going to be making around 150 to 300 passes to get to our objective. So which one's going to be easiest to work down from 3/8 of an inch to a 1/4? Ding, ding, ding. It's a given. So by doing that rough out, now that we're moving to our, and I don't need this stuff on the table anymore, I might as well get it off. What else do I not need? I may need that. I'm going to put it up there so it's not an eyesore. Now we're moving to our orbital sander. It's turning this way, it's turning this way, turning this way. Last thing you want to do is come over here and feed it from this way. You'll find out what happens as it shoots it out the back and sticks it in your drywall. So push from this side. This is our fence. It's turning this way. It's going up and down, up and down. The way you set it up first, put the 3/8 inch piece up there, and you should be able to push it through with ease. Then clamp that in place, or toggle that in place, or run some screws through the deck. Whatever. Well, you'd only be able to run one screw because this has got to be adjustable. Because you make that first pass, and then I'm going to exaggerate. Let's say we're doing this. That's our 3/8 of an inch. After you make that pass and you realize it's not catching at all. There's no high spots at all. What are we doing? We're surfacing down to a 1/4 of an inch. Now the next pass, move this in. I'm talking loosen up your clamp and go. That's all you're moving in. It's not even a 64th. Run the next pass. Because if you get aggressive, I'm gonna hit this once. If you get aggressive and think that you're gonna run this thing through here and eat it down from 3/8 of an inch to a 1/4 in 7 or 8 passes, you're gonna burn a rut in it, and you lost it. It's game over. You just ate that candy bar. So we're gonna make about 150 passes, and they're literally gonna be this fast. That's about the speed. Do you see how I flipped it over? Then I'm gonna flip it over. And I'm going to make my second pass about that fast. And I'm pushing with my hand. I can push my finger all the way up to that point and still be safe. And I've already got a grip on it back here, pulling it out. Flip it over. I'm continually doing this flipping over as I'm passing through it. And I'm not going to keep talking about that because that's self-explanatory. If you don't have an oscillating sander, man, go find one. They're one of the greatest tools in the shop because this is going to be a lifesaver when you start building your neck, or you've already used this because you've built your neck lower, and especially if you built an arch top. That's incredible for doing that shaping. So, all right, so it was easier to surface this down, and now you made that 200th pass, and you look at it, and you've been sitting here with your calipers, and you know beyond a shadow of a doubt, I don't know if that's in the camera, that is just a very small, thin hair over 6 millimeter. So that's a 1/4 inch thick surface. That would be finished and ready to put up on the jig. All right, I'll leave that on the table. I think the oscillating sander demonstration there. Get my template because I probably will need that again. Go online and watch some guys use oscillating sanders. They're incredible. Great tool. Very therapeutic too. It's a real quiet tool, real calm, and puts you in a good place. All right, we roughed out the taper, and we moved to the thickness sander to make 150 to 200 passes. Our target is a 1/4 of an inch. Number 5, let's verify the design per binding and our true target. The target should be clear, meaning your target should be clear by now. Either you're building a Telly or you're building a Strat, you're building a Les Paul, and you're doing binding. Don't build a Telly and put binding on it. Okay, you'll never get rid of that thing. You'll end up making a clock out of it. So we're gonna build a Strat. There is no binding, but I'm gonna talk about this as though we are doing binding later on, just so that it'll help cover all the bases. So in other words, you verify your design per your binding and your target. Why? We've kind of already done. Well, let me back up. I didn't cover something. Treat this fretboard as though you're not going to do binding. Okay, if the nut is going to be 1 11/16, then rough this out 1 1 3/4. If it's going to be 2 3/16, which it is on this guitar, it's a Strat. Let's rough this out at least 2 1/4. We've already covered that because we got to give ourselves space to make a mistake or change our mind. And because if we decide to do just a single thin piece of binding, let's say we were going to build a Les Paul Junior, and all of a sudden we realize, man, I'm getting pretty good at this. I got this stuff figured out. I'm just going to go ahead and build a Les Paul. Then guess what? You can't turn a Les Paul custom into a Flying V. Why? Because a Flying V doesn't have binding, but the Les Paul custom does, and that should make perfect sense. If it doesn't, just rewind and think about it. You can work down, but you can't work back up. All right, lay out bass and treble line trapezoidal path precise at this point and recut on the table saw. Now that we've got this thinned down to 1/4 of an inch, let's refine our design. Are we building a Les Paul Junior? Are we building a Les Paul Custom? No, we clearly said we're building a Strat. Stay on point. If we're building a Strat and it's a traditional Strat, let's say we're torn between whether we're going to do the whole, maybe we're thinking about doing a wide nut, and I better not start creating too many what ifs. If we're torn between our nut thickness, let's just go ahead and do it 1 3/4. Every one of my fretboards are 1 3/4. I'll cut them down later on. If I change my mind, then or either I'm going to sand it down to that. In other words, 1 3/4 is going to be my finished dimension. And since this is a Strat with no binding, I'm going to start out at 1 3/4, and then I'm going to be 2 1/4 up here. Now we're getting ready to go over to the table saw with our straight line jig with the toggle clamps and all that jazz, and we've decided, nope, it's concrete, it's carved in stone. I'm doing a 1 5/8 inch nut. That is a skinny little nut. That is small, but some people like them. Some people want them, and maybe it's going to be 1 1/16 thick. It's going to be a big old fat chunky thick thing, but it's nice and narrow. Why? Because maybe I have a disability. Maybe I have nerve damage and I can't handle a big fretboard, and I got to have some. I like that thickness, but I like a little bitty small because all I do is melodic playing anyway. I don't do a lot of chord work. So keep that. Make note of that as you're building. Build according to what it is will fit you and work for you, but try to keep in mind we're going to sell this guitar. Don't lose that. Don't lose that objective. We'll build that dream guitar at number 5. Right now, you're going to have a hard time selling a Telecaster or a Stratocaster neck at 1 5/8. Please don't go below 1 11/16, and don't go over 1 3/4. Okay, enough said. All right, lay out the bass and treble line, put it back on the cutting jig. Now we've just run a precision cut. I'm just going to say this is 1 11/16. This is 2 3/16. I've got the perfect length, but I'm not, now it's 1 11/16 here. But out here about an inch or two farther out, maybe out here, it might be as narrow as 1 9/16. And up here, it may be 2 5/16. I think that's understandable because that's where we're going to be fastening it to our jig. All right, and then after we've got that taper, and we know for a fact it's done, and maybe make one pass on, I've got some 48-inch belt sander paper that I just lay across the deck of my table saw, and I'll make one pass, or maybe 2 passes, and what am I doing? I'm just making sure that I knock any table saw weirdness off. All right. And then we're not worried about any of this squareness out here. It doesn't matter. We're going to be cutting that off later on because we've already designed a jig that will make our square cuts for us. Now we're going to attach it to the step surface jig per center line and clamp to your location that's most comfortable. Oh, what I meant by that is I failed to mention in the video. Is that in the video? Yeah, you can come back here with a cabinet clamp or your favorite clamp, and if you prefer to work standing up, well then clamp it to a high table. Clamp here and a clamp on the other end. If you're like me when I'm doing this, I want to sit on my bar stool. And I want to sit at my other table, which you've never seen. It's where all my tools are stored and organized, but it's also my workstation. It's a 24-inch by 7-foot door, 1 3/4 inch solid fire grade door, like a birch door, commercial door. They make incredible workbenches, and I'll clamp that onto that, and then I'll sit there on my bar stool and kick on my favorite music at that point because I'm not really, I you know, you need to stay focused on your numbers, but you can zone out and do your work. And once I get it in one place, because I know I'm going to be sitting at that bar stool for the next 2 or 3 days. All right. Because at this point, all work will be very delicate. You don't need to be over it with, a hammer and chisel. We're moving into real refined work at this point. All right, now is the time to do the final call about the scale length. And I know I'm creating a what if deviation, but if in the back of your mind you've really been toying with this whole, and I'm going to change gears. If you're building a Gibson and you're thinking, oh man, do I want to do that 24 and 3/4 inch scale, or do I just want to do that traditional 24 and 9/16? You gotta make that decision. You got to make it. Right now is the final call. With this fender, don't build a 25-inch fender neck. It ain't going to bolt onto anything. Don't build a 24 and 3/4 inch scale fender neck. It's not going to bolt on and be easy to sell. It's 25 and a half. Stay on point. So, but where I'm going with this, it is a final call to determine um, if I'm building a 50s Strat, well, I'm only a 21 fret guitar. As much as that drives me crazy, man, I want that 22nd fret. Don't do it. don't, don't do it because it's not correct. Know what your audience, know your consumer, and anyway, just go from there. But where I'm going is, if you truly were building a guitar neck that you know for beyond a shadow of a doubt, let's say this neck was the last piece of maple that your grandpa gave you before he passed. You gonna sell that on eBay? I don't think so. So, is that gonna be your first neck? It better not be. It better be your fifth. So, but let's say you got really gutsy and you just took a shot and you took Grandpa's prize maple that he gave you, and you're gonna build a neck, and it's gonna and you've clearly decided I want it 24 frets. Step right up. Then we're going to build a 24 fret neck. And what I'm saying right now is the time to make that call. If you're doing a 24 fret neck, it's got to be laid out much longer. So just know that right now is the time. Or if you were sitting there thinking, I'm going to do it 24 fret, and then right there at the last minute, you realize, why, I'm not even a very good guitar player. I don't know how to work beyond the 17th fret, blah, 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 blah. Then let's back up. Let's put our ego in check and let's build a 22 fret, or let's build a 21 fret. Right now is the time to make that call, because once we make that call, I say that you could still make that call later on when you do all the relief cutting, but once you start doing binding and mother of pearl, it's pretty hard, set in stone. And I've been doing this a long time. I really struggled with building my 59 replica as a 24 fret guitar. That, by most standards, that's absurd. Nobody wants that guitar. But why did I do that? For the main reason to prove it's not a fake, and I'm not trying to rip anybody off. And if that guitar ever passes into somebody else's hands, they could relic the devil out of it if it was a 22 fret guitar, and they might screw somebody over. But with that 24 fret on there, they ain't going to screw anybody over. All right, so now it's time to revisit the fretboard calculator sites and verify actual nut location is okay. You're getting ready to start making some marks in the wood, and make sure that the board is long enough for your overhang, which I've already discussed. And now we're all squared up. We've determined how it is we're going to cut. Make certain that we keep our saw that we're going to use square. And I'm not saying close. It has to be precise. But we're not going to start with this yet. We're going to start with the X-Acto knife. And let me check the time. It may be getting a little bit long-winded. We're at 35 minutes. And that's okay, because I'm already at point number, I'm already at point 9. Cut nut location and stop. Triple check everything, especially the scale if you transferred from online information to paper in hand. I'm going to cover this so I don't forget it. I'm bad about going online and taking a pen and writing down 25 different measurements. That's not wise when you're doing something like this. I would really keep your cell phone close by and, like the Tundra Man fretboard calculator, opened up, and just make certain that you know how to read his chart. I call it a graphical representation. It's not, it's a chart representation of the scale in either SAE or in metric. And believe it or not, even though I work primarily in SAE, when I'm laying out a fretboard and all this stuff, I don't even look at the SAE. Everything I do it in metric. It's so much easier. Is that always the case? No. A lot of times it's easier for me to work in SAE, but make that judgment call on your own. But be careful splitting 25/64 down to what, you know what I'm saying? Just proceed with caution. Sometimes it's easier to just look at the metric and go, all right, it's so and so, so many millimeters, 0.5. Well, then that's right in between this tick mark here on the left and that tick mark there on the right. A monkey could do that. I've just found center, so I should be okay. All right, and again, this is very cowboy. Everything I'm talking about doing here, you couldn't set up a luthier shop and do this. So we're not going to discuss how you would do that. You could buy 10 necks from or fretboards from StewMac before you could set up to build 20 and make any money at it. All right, so I almost digressed there, but we're going to cut the nut location, then we're going to stop, and we're going to triple check everything, especially the scale, if you transferred it from online to paper. I did cover that. Now at this point, we're going to mark all fret locations, and we're going to triple check it again, then score with X-Acto knife. And let me see if I need to clean up the tape a little bit here. I'm going to see if I can just pull this over and show in a very simple way what I'm talking about. Let me just stop for a second and put this back together. All right, I'm going to put my knee down there. That may shake the camera. I want that to be below the surface. I'm just going to guess at this because I've already cut off this bottom. I'm getting ready to do the binding, and look at the camera. See what I got here. This should be able to work. And I also want to make sure I don't lean forward and get my head in between the camera. Let's just, and I'm not really going to go too deep into this, and I'm going to show you a mistake and how to correct a mistake. Let's just say you're down here, and this is your the nut location. So I don't know how well that's going to show up. Is this how I did it? Absolutely not. But I'm not going to show you how I did it. I've got this. I got this piece of heavy aluminum, and it rides along, it rides along back there, and then it comes across like this, and I mean, it's NASA. It's NASA quality. Even though this is wood, it's insane, and I can put it over here, and it's when you know that you can cut one line there or cut that same line from there, you know you're spot on perfect. So basically, you could build something like that if you wanted to, and just have. Let me see if I can slow down a little bit. Something like that, but or you could also do this right here. You got that. And why do I like the poplar? It's easy to S4S on a table saw. I wouldn't trust maple because the maple might look square, but then it is not square. So basically, you could come in here, and where do we want to start from? Do we want to start from the nut location or the beginning of the fretboard, or do we want to start from the end of the scale? Let's always start at the nut and simply come in with your make sure I'm not getting ahead of myself. Yeah, this first one, we're going to go ahead and score. We're going to go ahead and don't try to cut in your first time. Make 10 or 15 passes. Now, keep in mind, not nearly as sloppy as I just did that. You're going to be making very assured scores because once you're starting that point, and then you can flip the X-Acto over and you can truly score it. You're truly scoring. It's not cutting. So now that you've got that defined line, now you can come in with your little cowboy jig that you've built with the squaring tool, and then you can take your woodcraft. This is true. I can't pronounce that. Maru, Choichi Maru, who knows? In Japan, and flush cut. It is positively, bar none, the perfect width for doing any online frets, like STMAC frets. It's a perfect fret slot. And I can make that first pass with this little tool, assures that I stay nice and square. Do I do it this way now? No, not really. But sometimes I will, because this is pretty easy to do. I'm making that first mark, but I'm making it right there. That's the top of the nut. I just did that to show on camera. Now I need to get in gear because I've probably wasted time. At this point, once you know the nut location, now you can make the decision about coming in with a precision straight edge. And I'm going to lay them out in metric, and I'm going to be a little bit more cowboy because the weight, the balance. I'm going to go up here and I'm going to set the starting metric figure on 500 millimeter, and I'm going to lay it out. Which to me, 500 millimeter is the same as 0, because 510 millimeter is the same as 10 millimeter. Self-explanatory. I'm going to lay everything out based on that. I'm going to clamp this in place. And then I know that when I come in here with my utility, I'm with my X-Acto knife, if I do a little scratch right at the center line with this X-Acto knife, and then I have quadruple checked it with my online calculator, and if I had converted it to paper, what I'm going to do is time to pull up your cell phone, and let's make sure you're not human. We are human. We make mistakes. So if we made just a little score scratch mistake, that can be worked out over the phone. But if you really got gung ho and started doing full blown score cutting, then you may have just lost your fretboard, or you may be in here with a router routing out frets between number 11 and or number 9. What is that, 9 to 1, 3, 5, 7 to 9? You might be in here routing out the whole location of number 6 and gluing in a fillet because you screwed up and you might have done whatever you did, wrong. So, or you're having to cut out 3 different slots. I've never had to do that because I triple check this before I do any scoring and cutting. And then how did I cut this fretboard? Exactly like I just showed you with that little handheld tool. That the whole thing was done by hand. All right, so you see, and if anything, if you're really serious about doing this, you ought to be able to. I hope I wasn't in. I hope I didn't get my face up in the camera and make a fool of myself, because I don't. Not that I'm embarrassed about being seen, but I want you guys to see the project, not me. All right, so I lost my train of thought there. Well, if it's important, it'll come back to me. Triple check everything. And then at that point, then come across with your scoring. And once you know your tick mark locations, then do your real gentle scoring. Flip the X-Acto blade over and do some fine scoring, because then you're going to come in with your fret saw, the little Japanese fret saw, and you're going to start really cutting these slots. Why do I say use that blocking right there? Because it's amazing what your eye will show you is rarely ever perpendicular, and these are critical, because this fret, the tang, we're working in very small, very unforgivable arena here. If your fret slot is funky in the slightest, it's you might as well turn it into a clock. You got to make certain that these are perfectly straight up and down. That ought to be self-explanatory. If you're doing something like this, that ought to be natural that you're that detail oriented. All right, we've already cut the nut location. We've triple checked everything. We've marked all of our slots. We've scored them. And now we're beginning to make all of our cuts. As far as your cuts, don't go very deep at this point. Maybe just go maybe a 1/16 of an inch deep, maybe a little bit more, maybe a millimeter. I don't know. Who knows? Just don't try to go all the way down right now. Why? Because we still have a flat S4S 1/4 inch board, and we're not ready for that finish work yet. Now it's time to, now that we've got all of our fret slots cut and roughly a millimeter deep, or a 1/16 or maybe 3/32 of an inch deep, now it's time to start drilling for our dots. And I don't know about a strat, a regular strat. I think it might be at the 3, 5, 7, 9, 2 at the 12, and then you skip the 13, you go up to 15, and there's only one, and then 17, and there may be one at 19. There probably is, but I don't think there's one at 21. I know there's not if it's a vintage guitar. It may even stop like the Gretsch Penguin. It's weird. They stop at, I think 13 is the last one, or maybe 15. Neither here nor there. When I talked about doing this on the drill press by hand, I'm not talking about sitting up here with a drill. I had a spiral router bit, and I had my drill press. I could change the speed up to, I think, at 5,000 RPMs, running extremely fast. Probably should have run it even faster than that, but then I set the depth on the drill press at, this is very important, uh, don't drill, um, don't drill, whatever the thickness of your mother of pearl is, know that you've done a real good job, or you should have done a real good job with a flat surface at this point. Don't drill down deep and think that you're going to load it full of epoxy and bring that mother of pearl up. That the weight of that mother of pearl will actually settle down into a bed of epoxy, and you'll come back the next morning and you'll be well below your 1/4 inch, and guess what? Game over. So make sure that your mother of pearl, if you do a pearl, rides a little bit proud of your target 1/4 inch thickness. So that ought to make perfect sense. But I came in here with, I started in the middle and just did like 1 or 2 passes. I'm pretty cowboy. I set the I set the drill press down. I held the drill press down, and I took my left hand and I moved the fretboard, and I basically moved the material, and I used the drill press like a router, and then I raised it up, went over here, dropped it down, locked it, move. No, look me, I'm moving the router. The bit is fixed, so I'm moving the fretboard back and forth. Why? Because I'm massing out a hell of a lot of material there. I'm not going to take a chisel and chisel that whole thing out. I saved that for the end, and I used my chisel at the very end, and I came in and I did very precise clean corner squaring. It's just like mortising the hinges on an architectural door. All right, but you're using sometimes. Well, on that one, I was using my large surgical chisel, and I'm not going to go into which side of the chisel should you use. Should you use the radius side or should you use the flat side? You ought to know that. And anyway, let's move on. Cut a fret saw first pass. Drill fretboard dots or machine on a drill press for mother of pearl or inlay work. I use the spiral bit with the depth set, roughly a 64th of an inch high, and then I epoxy the mother of pearl in place. Okay, and you're thinking, okay, so he probably put the black tint in the epoxy. Yes, in case there was squeeze out. But at this point, I didn't want squeeze out. They're not going to be perfect. Why? Because I'm not a CNC, but they ought to be perfect, or right at that threshold. But you're going to have little bumps. You're going to have little scratches. You're going to have to do little repairs like that. And but when you are aligning, let's say the hole is a little bit big, and you're aligning this mother of pearl, you better be able to see it. So if you've got too much excess epoxy in it, you got to have enough epoxy to cover the surface and make certain that it's bonded. And I do put just a little epoxy on the back of the mother of pearl, and then when I press it in, if I have squeeze out, I get it clean off as quickly as possible. Why? Because I've got to visually make certain, especially on something that big. This is why Leo Fender was such a genius. He didn't do this kind of stuff, and I almost call it crap. But if you're doing a mass-produced product that you're trying to make money off of, man, this is a nightmare. You got to be really, really good to do stuff like this. Whereas Leo was like, just drill some holes, drill some dots. Now Gibson was probably already doing that, but how many Strats or Tellys that have changed the world of the music industry had rectangular? You see what I'm saying? It doesn't matter. That you think what's his name? The guys for the Rolling Stones. I don't even know his name. Keith Richards. You think he gave a care that he had dots in there? Oh man, he's a multi-mega millionaire and still going. I guess he's still there. So if you're just drilling these holes in, you could do this same spiral bit and just drill it in the center. Be careful. You got it. Once you make that drill, especially in the maple, it's game over if you mess it up. So anyway, I almost digressed there, but just epoxy those in place and keep an eye on them. Great thing about the 24-hour cure epoxy, if you have to, you can stick a toothpick in the corner to make sure it stays perfectly in line. Because once I install the fret, oh man, I lost the frets. Just read my mind. Once I install the fret in these locations down here, I hope that's in the camera. And let me see the time. We're probably at an hour and a half. We're well into 50 minutes. If I install the frets down here and that mother of pearl is off just a hair, and it may be. I don't think it is, but man, it's really difficult. All right, let me hurry up and end this video. Epoxy in place, the mother of pearl dry, and we haven't even gotten to, at this point, the next day, we're going to come in and flat sand the board just with like one pass of like a 400 grit, and then we're going to make little repairs like this. And I'm going to see, because that was a little bit had a little bit of a gaping hole there. I hope that's in the camera. If it's not, it's too late. And I don't think I got long-winded in any of this stuff. It's just what I meant by when we're building the fretboard, it's going to get mind-numbing. All right, how would I make that repair? What would be the next move? I'd probably come in with a razor blade and don't start scraping across. You'll start scarring the fretboard. And don't use a chisel. Do not use any sort of cross-cut file. If you're going to use a file, use a machinist file at this point. And then after it's all said and done, then take some 400 grit sandpaper, come in here and just do some sweet, gentle sanding. These right here at this point, once I got it to this point, it's time to radius. Okay, now you're going to go through your whole radiusing process. I've already covered that. I'm not going to go over that again. or I covered it enough that you should be able to figure that out. And then at this point, you're going to install the binding. And then once the binding is installed, the binding, if your binding is really, really tall, then let's go ahead and pre-trim it. But don't dare try to pre-trim it down to a millimeter away. That binding right there is about an eighth of an inch proud. That's exactly what it's going to look like. I'm not going to dare try to make that binding any shorter than that. Why? Because I can run my radiusing tool across that with the jig, and I'm gonna, and then have a perfectly. That's a real good way to show it. Then whatever my radius is, it follows into that binding on the outside. Why? Because my frets, because since I have binding, are going to have the tang nipped on each end, and my frets will go out like a authentic jazz guitar. I do not do the fret nibs on the end. I don't do that type stuff. So we're not having to worry about that. But why? Because we're building a Strat. All we got to do is just let the fret run right out to the edge, and then we're going to put a 35-degree angle on the end and roughly rough it all out. I'm just sand it smooth. So I covered a lot of stuff real fast, and I hope it's under an hour, but we'll see. We're at 55 minutes, 56 minutes. If you got a question, you better ask it fast because I'm about to turn the video off. So, what did I miss? The only thing I will say, if you wanted to, you could take a piece of paper and slide under this little thing to raise your sandpaper up a little bit. Maybe put 3 pieces of sandpaper. Cardstock paper. This is 60-pound cardstock paper. Don't take 60-pound paper and fold it over though. Cut individual pieces to put in there that will build your sandpaper up when you're really getting down to splitting hairs, and then take out pieces of paper and then allow that to settle down. And are we going to be using this again? Only to come across it and clean off the binding and level the binding, which will be in a compound, well, no, it won't be compound radius. It'll be in a 12-inch radius arc with the top of the fretboard. And if you're building a fender, keep in mind they're compound radius. You don't, and I'm kind of contradicting what I've said, making it easy. All the more reason to just buy your fretboard from Stuart McDonald. Why? Because they're under $70, $80. They got the fret slots cut. They're compound radius. They send the fretboards with 24 fret locations and the overhang. And if you don't want a 24 fret, you simply take your, if you wanted a 22 fret, I'm just going to say that's the 22 fret, and let's say you wanted a 22 fret and this is a 22nd fret, then all you got to do is take your saw and saw that fretboard off, and voila, that's the end of your Fender fretboard. It's compound radius, it has the fret slots cut, and the only thing you will have to do is taper it to your preference of what nut width you want, and then you'll only have to drill for your fret marker locations. So you see what I mean by, do you really want to build your own fretboard? Don't do it unless you just really, really want to challenge yourself. Okay, thanks guys. I appreciate you staying in the ring. This was a long video.